Okay, what is the shortest vertical distance between the parabola y equal x squared plus 1 and the line y equal 2x minus 1? We see from the graph that for each value of x, it appears that the distance between the parabola line is going to be the parabola is going to be above the line. So the distance is just going to be the parabola minus the line. Okay, so the d is the function of x. D of x is going to be the parabola, which is x squared plus 1 minus the line, which is 2x minus 1. And then if we distribute the minus sign, we'll get x squared plus 1 minus 2x plus 1, and combine like terms, we get x squared minus 2x plus 2. So the distance is x squared minus 2x plus 2. And this is defined from minus infinity to infinity. It's defined on an open interval, so we can't apply the theorem that about finding the extreme values on closed intervals, because this is not a closed interval. But we can still find this value, possibly find this value, because if there's only one critical number, and this a polynomial is a continuous function, if there's only one critical number, then the maximum or minimum is going to occur at that number. So that's we're going to proceed on that assumption. We take the derivative d prime of x. That's 2x minus 2. And if we set that equal to 0, we get add 2 to both sides. We get 2x equals 2 divided by 2, and it gives us x is equal to 1. So there's going to be a critical number at x equal 1. And then we need to sort of analyze the sign to see if it's going to be a maximum or a minimum. Make a number line here. So d prime of x is going to be 0 when x is equal to 1. And then if we put in a number less than 1, for example 0, 2 times 0 minus 2 is negative 2, so that's going to be negative. And pick a number more than 1, for example 2. 2 times 2 is 4, minus 2 is 2, which is positive. So that means that we have a negative slope, and then slope 0, and then a positive slope. So that means that this point here is going to be, it's a relative minimum, but actually, because there's only 1, it's going to be the absolute minimum value. So the minimum distance occurs when when x is equal to 1. Okay, so then we want to evaluate d of 1. D of 1. If we plug in the formula for d, if I can put that on here. D of 1 is going to be, here's the formula for d of x here. It's x squared minus 2x plus 2. So d of 1 will be 1 squared minus 2 times 1 plus 2, and that's just equal to 1. So the minimum distance is going to be 1. Minimum distance of 1 occurs when x is equal to 1. So that's here's where x is equal to 1 here, and this is that distance. So that actually appears, it's consistent with what we see on the graph there. It looks like the distance is about 1, and that's when x equals 1, and that's the closest one. And there's no maximum here. This only there's an open interval with only a minimum. There's no maximum. It keeps on increasing as x gets away from the minimum. Okay, so that concludes this presentation.